This is the 2015 Higher Level Section B, and it's question C3. The topic is surface geometry, which is pretty much the same as intersecting planes. It's the same idea. It's just a standard planes question. The graphic on the right shows a modern Irish building structure. Figure C3 shows the plan and elevation of the structure below. The outline of the plan is a square plan. It's pretty straightforward. We have to draw the elevation and plan of the structure. We have to determine the dihedral angle between surfaces A and B, and we have to draw the true shape of surface C. And then from that we have to draw a circle on it. We're going to continue to start with parts A and B to begin with. It's pretty straightforward to set up the elevation and plan. There's a little hint given in the question. It says draw the given plan and elevation. Plan comes first. They've said it first in the question. So they're saying draw the plan, then draw the elevation. Scale is 1:200, which means we divide all our measurements by 200. But 12 meters is 12,000 millimeters. This is 4,000 millimeters. And down below we have 1,440 millimeters. Sorry, 14,400 millimeters. So we have to multiply each of these by 1,000 first of all to get them in millimeters. Then you come along and divide them by 200. So your square and plan, 72 millimeters by 72, 60 millimeters, 20 millimeters, and then it's just a matter of finding the points. I've got the plan set up here and the elevation set up. So plan drawn first of all, it's pretty straightforward, and then it's just a matter of finding the points and elevation. Label the points as I have them. So we've got points P, Q, R and S, and the reason we've got those 3 points is we're going to start off getting the dihedral angle between A and B. So plane A is made up of points P, Q and R, which is P, Q and R. Surface B, or plane B, is made up of P, R, S, and we have P, R and S. Surface B can't be seen in elevation, so we can see it in plan, but it's hidden behind the roof in elevation. Dihedral angle, we do it always the same way. We're going to find an auxiliary elevation to see the true length of the line of intersection, and then we're going to draw an auxiliary plan to see the true shape of the line of intersection. First thing we need to do is highlight the line of intersection. Line of intersection is PR. So that is the line that we're concerned about. Everything works around that line. First thing we do is to draw an auxiliary elevation to show the true length of the line, which means we're looking at 90 degrees. So project off an auxiliary elevation looking in at 90 degrees to the line. To do that, come off parallel to the line in plan, project out at 90 degrees. And we're going to work with points P, Q, R and S. So we're going to bring all the points as we do it. Set up our XY line, which is parallel to that line PR, and we'll bring it out just to miss the other view. X1, Y1. It's a pretty straightforward question because when I bring out points P and R, Q and S go with it. So P, Q and S are all in the one line, R is in the other line. Height and elevation. Height of point R. Strike it off in our auxiliary. So we get point R. Q and S both have a height of 0. So Q and S, when we bring them up, are both on the XY line. And the height of point P, and we project it out, and we get point P. So I've highlighted the points. Our important line that we talked about was PR. that is our line of intersection, and then we have plane PQS. Sorry, we have plane PQR, so PQR, and then right in behind it is plane PRS. So surfaces A and B, one is directly behind the other here. That is our true length of the line. This is our auxiliary elevation. And that shows us the true length of the line and the true inclination. In other words, the angle it makes with our XY line. I now need to find the dihedral angle, and to do that we have to look in directly along line PR. So I'm going to project out my line of sight looking along PR, XY line as always at 90 degrees. X2, Y2. Straight away, this is an auxiliary plan, meaning all of my measurements need to be taken from plan, and all of my measurements need to be taken from the previous XY line. I'm at X2, Y2, previous XY line is X1, Y1. So I need to take all my measurements from X1, Y1 into plan. That distance is huge. So as always, we drag back the X1, Y1 line. And we call that the datum line. And we can put it as close to the drawing as we want. We can put a touch in the drawing, but I'm not going to because it confuses some people. So there's our datum. And now we can come along and find the points. Datum line to point R, we strike it off. Datum line to P is the same distance, which means they end up in the same place. So P and R end up in the same place. Q to the datum line is here, and I need to project out point Q now. So again, I've got my distance for Q, and I step it out. Project out points Q and S in the same way. Take my distance from the datum line to Q, which is here, strike it off. That gives me point Q. Take the distance to S, which gives me point S. Again, follow up point S, and that gives me S. Line of intersection looks like a point, and then my dihedral angle is shown because plane PRS looks like a line and plane PRQ looks like a line. Dihedral angle is here. You have to indicate the dihedral angle. There's a few ways to do part C of this question. We have to find the true shape of surface C. Surface C is vertical in plan, which is actually pretty handy. So there's a lot of the work done for us. Another reason a lot of the work is done is that we've already got this auxiliary elevation. If we wanted to find the true shape of a surface, we normally draw an auxiliary elevation to show an edge view of the surface, and then an auxiliary plan to show the true shape. We've already drawn an auxiliary elevation to show an edge view. P, Q, S is the 3 points on surface C, and PQS is here in the auxiliary elevation we've already drawn. So it's already done. It just happens that we have this edge view given to us. So we've got our auxiliary elevation already drawn, showing the edge view of the plane. Now it's a matter of looking in at 90 degrees. So we're looking in this direction. So when I come in, I'm going to look in 90 degrees to the plane to see the true shape. And we're going to draw an auxiliary plane. I'll set up my XY line. And project out each of the points. It's our X2, Y2. This again straight away is another auxiliary plane. Measurements have to be taken from plan. Measurements have to be taken from the previous XY line, which is our X1, Y1. We've already set up this datum line. So for me to find the true shape, it's pretty quick. All I need to do is take the measurements from my datum line to point Q, project Q out. Datum line to point P, project P out. Datum line to point S, and project S out. That gives me the true shape of that surface PQS. To draw the largest possible circle inside it, I need to bisect two of the angles. Any two, it doesn't really matter. So one bisected. And the second one bisected. That gives me the center point. To find the points of contact, I come off at 90 degrees to the edges. And have my point of contact here already. A point of contact on the other side. So that's using auxiliary elevation, auxiliary plan in two different ways to do two different parts of the question. So that's part B and part C done. Part D, the question asks us to find the pitch of surface A. That's a kind of sneaky way or an indirect way of asking the inclination, the angle of it. So we've got our surface A. And pitch is just a term used in roofing. You'd have heard it if you're doing construction studies. We want to find the inclination or the angle that makes with the ground. So the true angle. Always the same thing, it's an auxiliary elevation. So we want to get an auxiliary elevation to show an edge view of the plane. So we have our plane here in elevation and plan. We want to find an edge view of that plane. To do that, we take a horizontal line, any horizontal line, but a handy one is one from P, because I've already got point P. P, and I call that point L, just for any kind of label. Find that point, that line in plan. I have P already, take down point L. L is on line RQ. And we find point L in plan. That is our horizontal line drawn in plan. So we've got the elevation of the horizontal line, we've got the plan of the horizontal line. And all I do is draw an auxiliary elevation looking along that line. So project out an auxiliary elevation that looks along that line. Project out point Q and project out point R. P is already done. Again, same thing, XY line, just away from the drawing. X1, Y1. And it's handy to label your view. It's an auxiliary elevation. Means I'm going to take my measurements from elevation, and the same rules apply always. Measurements come from elevation, I work from the previous XY line. I'm at X1, Y1, here's XY, which is the previous XY line. Height of Q is 0, so when I project out, the height of Q is 0. Height of R. Here we have it. Follow out point R. Height of L and P are the same. L and P, when we take them out, at the same height. Project out L and P, they'll end up on the same point. What we should end up with is a straight line. My accuracy is just a little bit off because I'm rushing the question a little bit, but that is our edge view. Here is the ground, here is the plane, and here is our inclination. So I could measure that, but what they asked for was the pitch, so I call it the pitch. But again, it's just an auxiliary elevation. And the great thing with this question is auxiliary elevation, auxiliary plan, you can do the whole question.